Hello, how's it going today, guys? Welcome back to a video on Code Tech Tutorials. My name is Matt, your local, call me whatever you want. What are all these labels? Why does every YouTuber have a label? I don't know. That's side rant, total side rant. Just as an intro. It bugs me. That's the side rant. I was going to say your local computer scientist, but I feel like someone else has to give you that title. And I do have that title by the university I graduated from, but I still don't feel like it fits me because I have so much more to learn. So, well, this has been a bit of a humbling intro. Let's just get to what I was going to actually talk about. Ancient Archer. This is a game engine that I was working on and introduced a while back, and it really I just want to talk about what I'm doing with it now. It's been a while. Some people have asked. I did make a GitHub repo live without really announcing it, and yeah, I just want to walk you through my thought process, my design process, what's happening with this, because you may have noticed already if you've seen any of the previous videos, this is nothing like what was going on before. It's very different. So I'm going to show you basically what I did. So I'll leave a repo link down below, and I'll probably push this branch as a restructure because that's what's going on, a giant restructure. There's, as of right now, there's a master branch, which is a very old version, and it's just, it has a lot of stuff. It's cluttered with a lot of includes and libraries and stuff that is somewhat optional if you're a game developer, because you might want to use something else. So one of the big things I was doing, well, originally I was kind of just building something to get any kind of game done because it was for a graphics class, and that's what the assignment basically was. And then, and that was a big hack job basically, and I got through all that stuff, and then I really just enjoyed working on it. So I kept working on it, kept it alive, kept expanding it, kept changing things, kept adding things, and it was getting big and convoluted, and I was getting lost in my own code. So I kept just reanalyzing things and kept wanting to go back to the core stuff and learn more about how I should really be doing includes and how I should really be thinking about libraries, and how I should be thinking about how much memory everything's using and stuff like that. So there's just so many different angles I have to try to think about this engine from, and most of them are dynamic. So that's what really got me stuck, oddly enough, is if all this stuff is dynamic and you can plug in whatever you want whenever you want, then why am I going to force a user to use this library that I chose at one point, or OpenGL rendering because that's all I support? That doesn't really make any sense from a game engine perspective. So I thought it would make more sense to really work out the core loop, sort of how the game would be designed, and leave the rendering up to the end user. You want to use DirectX 11, 12, OpenGL, Vulkan, okay, go ahead. But and those, all that object handling and animation handling can be fixed in by the proper libraries for any of those, and there's lots of open source ones. So no need for me to redesign all of them from scratch again. But and it took me a while to figure a lot of this out, but basically when I was in school and learning it. See, here's the thing about computer science. I guess I'll go into a little rant about what taking computer science courses were like. Computers, getting a degree in computer science and going through all the courses, the proper curriculum, the thing I began to notice about this particular 4-year degree is they basically teach you to build everything from scratch. There's a lot of other degrees where they just be like, just use this tool, it's fine. Just use this tool, it's fine. Just use this tool, it's fine. In computer science, it's like, here's Linux, here's build this tool. Here's Linux, build this tool. And So you just get used to doing everything yourself, basically, and being as unreliant on third parties as you can. And it was, at times when I was more naive, I didn't even realize there were libraries for stuff like all the stuff I was already building. But at the same time, it's kind of good because me not realizing that there's something already done really well made me want to build it and go about it my own way. And that's how you get good at this stuff, is you just practice. You dive in, you make the best you can with what you got, and you just keep learning and you just keep improving. So that's like the secret to computer science that nobody really tells you, is you just have to dive in and do something and keep doing something. Heck, as an example, the most popular repo on my GitHub is abysmal code. Yeah, I said it. I've thought about refactoring it for like the last year, because it seems like every couple weeks I come up with a better system of something I was doing before. And I see that all over the place with my most popular repo, which is the Empower. It's a Dungeons and Dragons little command line thing. I could do that so much better now if I took the time, but the code base is so huge that there's just no way I'm going to set aside a week to redesign it. It's a total side project I was just doing for fun, but I learned so much about handling console input and a lot of tricks with that, and just about managing logic just by doing that program. And that was not an assignment. That was just something I just felt like doing. And that in an odd way, like going through the courses in computer science kind of got my head in the right place about, realizing what I could do from the ground up. But actually doing it on my own is what made the difference. That's important. That's really important. Going to school doesn't do anything, doesn't make you anything. But you actually wanting something and making it happen, bringing something to fruition that wasn't there before, just by your own ideas in your own mind, that's something special. And now here's the part where that all falls apart. And that is everything's been done already. Good luck with that. So, like, the problem with DM Power is it's entirely copyrighted data. Dungeons and Dragons owns all that data. I just organized it to a command line format that I liked, because I liked command line at the time. And apparently other people kind of think it's cool too. But if I were to ever like ask for money or anything for that program, or say like you can donate here to support the project, I would get sued by Wizards of the Coast. So, well, I don't know. They'd probably just cease and desist. I don't really know, but it's a thing. I've looked into it, and yeah, I literally can't make money off that program. So I guess the point is, if you're going to be original and you want it to be increasing your like intake somehow, there's multiple ways of doing it. You can do it completely original, or you can just have, you can get experience under your belt, and both are valuable, because without the experience under your belt, you can't do the other one of making your own original thing. So it's a tricky thing of, you just got to do some research, some trying things, some figuring it, maybe implement systems that other people have designed for you and things like that. That's something I'm always looking for. I'm always looking for someone that wants to design things, and it's so hard to find someone like that, because if you throw me a design and like a layout of how things should work, I can program it. That sounds really fun. But if I'm left to design and then program, it like at some point it overloads my brain, and I need to step back and rethink, because I'm like, am I designing this right? Do I need to design or program right now? Design or program? And sometimes I would just get stuck in that loop of, I'll start to program something and think, oh, I don't want to design it like this, so I go back to design, and then I think about it a little bit, or maybe I lose track of where it was or something. I don't know. It's flopping back and forth is not good. It's not the most healthy work pattern. So it's best if you can focus, and if I can focus on a design, I can get it done. And that's typically how I get my bigger projects done, is just a lot of focus. And it takes a lot of time. You literally have to make time for it. Like, for example, I've found that it's nearly impossible to program around kids. because, you know, kids are noisy, they're distracting, they want attention, and that's awesome. But that doesn't allow your brain to go into programmer mode. At least not for me, but I can sometimes. It just depends, especially if I'm like showing the code that's kind of different, or if I'm building something like that does something, you know. I guess it could be, everyone's different. I'm just ranting at this point. I don't know how much of this I'm going to leave in the video. Okay, so Ancient Archer. I've reduced it down to a main loop, and I'm not entirely sure I'm happy with this. And the main loop is a static library, so everything else is just a demo from it. So the main loop is the crux of this, what this engine is, and it's very simple. So all that other previous code I did, it's all whatever, it can all be replaced. But this code right here, these 24 lines in a header, whatever it is, 24, yeah. These probably won't be changed very often, if ever, and they can be used by any program at any time. And all this really does is sets you up a while loop that allows you to interlude timing. And it's sort of designed in a way that thinks about like an update and then a post update. So you have like your main stuff going on, and then you have the display of the results. So that's basically what it does. So what you do to use it, I'll show you in console demo text. Okay, well, this just asks you which one you want to run. Okay, so let's look at an implementation. And here's a very simple one of just a little console game that doesn't really do anything, but it's just like a sample of what you could do. So I'm making just a little struct here to play around with. Then I'm implementing it. I'm making it static because it's within the function. If these were declared globally outside of the function, they won't have to be static. But if they're in the function, any of your variables have to be static, and that's so you can use them and access them in these lambdas that you're going to make. So you got to get really used to lambdas here, because this is all built around adding functions to the loop. Okay, so I've declared a player name, and an action. And then I declare my main loop, and to get it, we just call init on the main loop. Usually I do this auto, but it's a shared pointer to it, so this you can see it explicitly what it is. Then I'm going to make a keep running bool, because the way I design this main loop, you got to give it a run condition. If you don't give it a run condition, it'll just exit right away. Thinking about changing that a little bit, but for now, one of the things you have to do is just set a run con that returns true or false. So all this lambda needs to do is return true or false. I'm going to keep a keep running variable that it's going to return. And on begin is before we go into the main loop, the while loop, the main while loop of the engine. So we're going to go ahead and add this function to it that just says, well, on begin is like an on user create, so it's a one-time run. So we're going to set keep running to true, and we're going to say some intro stuff to the whoever's playing. It says welcome to a new game of trainer, enter your character's name, and it does a get line and saves the player's name. So it does that once on start, and then on every update it runs this. It says enter an action, and then it kind of tells you attack, train, or quit are the valid options. So it does a get line on action, and if you typed quit, keep running is changed to false. If you typed action, or if you typed attack, and I just put some random logic in here. If your player's strength is over 4, you gain experience. And if your experience is over strength, you gain HP. It's just some random logic. You can put whatever you want in there. I need an enemy really to attack or something. And then if you type train, it makes your strength go up. So just some little basic stuff to play around with and make sure they change. And then we have a post update. This is essentially the render. So after it does all the updating, and you can add as many of these as you want, and they are added in the order that you add them. So, or they are processed in the order that you add them. So when we run this, it'll just keep asking this question on the update, and it'll keep displaying the results. Of course, it's going to hold at these get lines, but if we didn't have a blocker, will block the, it'll wait for you at this point. The loop will just keep going over and over if you don't have a blocker. So there we go. And I made a little demo here that's sort of more of an AI. So a sample of an AI. And I'll walk through that one next. Let's run this, ask how my day was here. There we go. Set that as the one to run, hit play. We'll do the text only RPG, and here it goes. So we can type these in. It does a check, it does a thing. This is really all it does, just a little sample. And if we type quit, it leaves. But it goes back to a while loop. So the other one does a very similar thing. It inits. This time I use auto. And we add to on begin just a hello. And then we're going to keep a few statics. We're going to keep a your reply and the keep running bool. We're doing the same thing with the keep running bool. We just set it to true on begin. That just gives us something we can toggle when we set the run con. You basically just do this anytime before run. Once you do ML or the main loop run, then it takes off and you can't do anything else till this returns. So this actually returns a value, which is an int, and that's just to signify how it went. Yeah, we don't really need it for anything there, and that's why we're not saving it. But the point is, once you hit run, it goes through all the stuff you set up until you quit. So you got to have some kind of keep running setup. I've got to think about that a little bit. There's probably going to be a better way. See, the way it was in the old engine, and the way that was not very compatible in the long run, was I used to have it just check if the window closed. And that's how that was my exit condition, was did the window close. And that's not the best way. It should shut down the window by going through your process, because maybe it's got a memory that it needs to free and stuff like that, Okay, so we add three things to on update. We add a how was your day, and then it gets line your reply, and then it spits back out good to hear you are whatever you said, good luck with that. That's all it does. And then it does another on update, and this update is well, it's just cout's a string, or okay, yeah, I'm trying to remember what I typed. It basically sees if you type the word bad anywhere in your reply, and if you did, then it says hope it gets better soon, stay strong my friend. So it just checks if you said bad anywhere, and then it just says something positive to you. And if you typed anything regarding the word quit, then it exits the program. Keep running is false. And of course we set the run con. We could do this earlier. I usually do this like up here, but as long as you do it before the run, as long as you have those set up before the run, it's good. And that's all that one does. And it's still running in the background here. Let me see. There it is. Okay, friendly robot text chat. Hello, how was your day? It looks like it picked, I need to clear an input there because it just ran through it. I'll type good, and it says stuff. Type random stuff, it spits it back at me. But if I type the word quit, then it quits. All right, and this one's a number. All right, so that's just some examples of kind of how to use it. Now, ideally, if you're using graphics, then things will be different. You can still use this loop, but you want to involve delta time. I didn't use any delta time there. And where delta time comes in, well, we'll just say it is supported. So let's just look at the source here a little bit. So we're in the main loop.cpp, and so once we do run, it goes through all this stuff. If it's not initialized, it initializes it. So you can literally just type this main loop run, and it'll run the engine, but it won't do anything because nothing's set up. It'll just exit right away, basically. It'll run through all this once and exit because there's no run con. Okay, so it runs to begin, then it while loops while checking your run con. And one in this while loop, it does the update and it does the render. And then at the end, it does a teardown, so you can set up stuff that needs to be dismantled in the add to teardown. All right, so let's look at this update a little closer. I'm holding some statics in the CPP of the delta time. So in all these functions, I can use delta time. And what we can do with that is on our update, we can have a delta update, and then we can just have a standard always updating without delta. So every frame, we can run this on delta update set of functions and pass it the delta time. And that allows us to use our delta time and functions and design it our own way. So let me go to this console window graphics demo. Set startup project. So this is using the old trick of just making a console screen and a handle, which is the console screen buffer, and set it as active. This is a Windows thing. And I actually got this from Javid X9. Well, most of it. I kind of rewrote it my own way, but he sets it up in his console game engine thing. And it's basically just this here. But normally he makes a while loop. So the point of this was to basically use my while loop in what he set up. And it was a great test, a great way to test the delta time and to make sure that this could actually run something on timing, because that's what we need to know before we go to real graphics is, can we get everything timed correctly for when we're animating and stuff like that? And if we can, then this is a great little main loop to use. And then we need to test efficiency as we go and stuff like that. So it's gonna be a good run. All right, so I set this as the startup, and I just want to walk through this real quick. So this is just a single file to run in here, and it has a main. So I've got all of these declared as global, so I don't need to make them static to access them in my lambdas later, since they're outside of the main or outside of any function. But I do have some statics for this console screen stuff, and that's so I can access them within my lambdas that I add to the on update and on begin and stuff. So we got a little map, just a big string. We've got we set up our main loop here. We just do a main loop .get, which is exactly the same as .init. I just made both of them because they're both so common and they both return the main loop. So you can call get or init. And as you can see in the design here, there's get, it just returns main loop.init. So the init makes sure, so if it's null, it initializes it, otherwise it just returns it. So we don't want to keep reinitializing it. And the main loop is within this, there's only one main loop allowed. I haven't got to threading, but I guess the next step in this main loop would be to allow some kind of threading. I got to think about that some, but for now it is just single thread. But it's probably going to be pretty easy to implement threading if this is all kept very clean. So that's sort of the point of this, is to keep it really clean, add things very carefully, and we'll go from there. Okay. All right, so we get the main loop, we set the is running stuff. So we set the run con to return this is running bool. We set it to true on begin, and then we start adding to our updates. So we got some keys to move forward, or I'm sorry, look left and right, look forward, or move forward, move back. And now a lot of this, maybe I'll link to Javid's video, but he basically set up first person controls in this console, and it's an open source thing. I'll link to it below, but it's not, I just don't want to claim the work because it's not mine. But this is actually, I don't know if it's even claimable, because this is very straightforward code. Like anyone that uses get async key state from Windows, it's just included in the Windows header, will do it about the same way. They might have some optimizations here and there, but this is how you do it. You see if A is pressed, see if D is pressed, see if W is pressed, and then process some things. And now as you can see, this add to on update has a float DT right here. So you can name this whatever you want, but this one is overloaded to look at the delta time. And that way you can grab it from the engine here and run it through your entire function. So I'll show you that in the main loop here, implementation. There it is, add to on update, add to on update. There's two of them. There's one that doesn't take anything, and there's one that takes a float. So when we're actually running and we're doing this update, first we do the delta updates and we pass it the ticks of delta time, which is just the delta time. And that's through the duration chrono library. And there's our just quick little setup. It's all the timing is basically handled right within that highlighted code right there. So that's all it takes in the library to get delta time throughout the entire, I guess your entire program. So it's simplifications like this where just the entire thing is encompassed in one spot that make it really nice. Because if there's ever a bug with the timing, I can just go right here and critically analyze 10 lines of code basically, rather than having to jump all over a code base. All right, so we add it. So now we have access to this delta time based on how it processes this on update, so we can use it within this function. And as you can see, that's where when we turn, we use delta time. When we move forward, we use delta time. When we move back, we use delta time. So that's why this particular update is in the delta time one. So we do another one here. This one doesn't take delta time because we don't need it anywhere. Now this is just setting up how the screen should look before it draws. That's basically all this does. So it takes the player position into account and how the map looks, and it sets up our map, which is just a giant vector W string thing. There it is. And then based on how it is, we do an on post update, which is the render. So after everything's updated, we check that console screen. I think we set it to null first, and then we write, yeah, so we blank out the screen and then we write new stuff over it, as I believe how that works. Write console output character, and we're taking all the stuff we updated, which is basically these variables here, not the word bytes written, that's just there because it has to be. But we take the console screen and the handle console and the map, well, just the console screen and the handle console really, those being all updated, and we just pass it all in like so, and it updates the console. So let's hit play on this. And there we go. I'm kind of seeing what you see in Javid's video, but this time I'm running on my own loop. And if I press A, it goes left, and I press D, it goes right. I actually haven't got through all the code on his video, so I haven't implemented the corner things he did yet. I kind of just left it at this because I was like, all right, I see that it works, good enough. No need for me to do the rest necessarily, unless I want to get more technical with this demo. I have a bug with W and S where for some reason they like zoom you really far. I'm not sure why. I've looked at the code and I don't see what's wrong, but apparently something's wrong with these particular functions that zoom you really far. I gotta look again. Anyway, so it does work as a main loop for that console window engine. No longer need to use while one, Javid. No longer needed. Of course, this is additional overhead. While one is very, very cheap. But this main loop does give you some things. And in further testing, I'll find out if it's the kind of loop I want going forward for this engine. See, and the whole point of this is now you can plug in anything you want into this loop. This is basically your engine. You can bring your own logic. You can bring your own renderer. You can bring your own whatever you want, and this will work on. This is universal code here. There's no inclusion of Windows only on this main loop. This main loop will run on any OS, and how you want to build around it is up to you. This is just a static library of a main loop. So there you go. I think that'll do it. Thanks for watching. Thanks for tuning in. Don't forget to like and subscribe. Let me know if you like these type of videos, and let me know what you think. Peace out, guys.